When solving rational expressions, sometimes it's easy to help break down both the numerator and the denominator into its individual factors. So for example, if I take a look at the numerator here, that is 21x to the third. That is 7 times 3 makes up the 21, and there's 3 x's because of x to the third. If I look at my denominator, 35 x to the 7th, that is 7 times 5 will get you to 35, and then 1, 2, 3, 4, 5, 6, 7 x's. So when we're going to simplify this, we're looking for common factors in both the numerator and the denominator, simplify and cancel out. So we have 7's in both the numerator and the denominator, and we have 3 x's in both the numerator and the denominator. So our final answer, the only thing left in my numerator is 3, and in my denominator we have a 5, and we have 4 x's here, so that would be x to the 4th. When we have expressions that are already in factored form, we can just look to see what common factors we have in the top and the bottom. So in this example, we see that there is an x minus 3 in the numerator and an x minus 3 in the denominator. So those will cancel and simplify out, leaving us with 2 over x plus 4. In this example, you can see that both the numerator and the denominator are not in factored form. So we want to look to see if we can factor both the numerator and the denominator. So my numerator has two terms, 10x and 15. So we're going to look to factor out a GCF for both of those. Basically, what's the greatest common factor that can go into each one of those terms, and in this case, it's 5. So if you factor out a 5, you're thinking, okay, 5 times what would get me back to 10x? Answer to that would be 2x. All right. And then 5 times what would get me to negative 15? And the answer to that would be negative 3. Now I'm also going to look for a GCF in my denominator. I'm going to factor that the same way I did my numerator. So in this case, my GCF is also 5. And 5 times 5x would get me back to 25x. And plus 6 would get me back to 30. So now that it's in factored form, I can see what we have in common on top, what we have in common on bottom. In this case, the 5's can cancel out, leaving me with 2x minus 3 over 5x plus 6. Now some people might want to try and cancel out, say, these x's, but we can't do that because this term is 2x minus 3. So if I'm going to cancel out anything in the numerator, it has to be a full 2x minus 3, which we don't have in the denominator. Now this example gets a little more complicated just because in our numerator we have a trinomial. Trinomial meaning we have 3 terms, 1, 2, and 3 in our numerator. But we're still going to do the same basic principles that we've been doing, in which is we want to factor. So we want to factor, and then we want to simplify. In other words, cancel out. So if we take a look at this part right here. Now when we factor trinomials, if you remember back from the quadratics unit, we have 2 binomials here. We put an x here and x here. Since x times x would get me back to x squared. And now we're looking for 2 numbers that multiply to be negative 15, but add to be negative 2. So 2 numbers that multiply to be negative 15 and add to be negative 2 would be negative 5 and positive 3. In my denominator, that's just a 2-term binomial, so we're going to look to factor out a GCF. So the greatest common factor that goes in these 2 terms is 4. So if I factor out a 4, I'd be left with an x, and then 4 times negative 5 would get me back to that negative 20. Now that everything's factored, we look to see what we can cancel out. Alright, so we go to step 2, and I see that I have an x minus 5 on top and an x minus 5 on bottom. Those will cancel out. So I'm left with an x plus 3 over 4 as my final answer. In our last example, we have a trinomial on top and a trinomial on bottom. So we're going to factor these. Remember, we're looking for numbers that multiply to be those last numbers, but add to be those middle numbers. Alright, so if I were to take the top part, so we'll do the top part, and we'll do it in teal. Okay. X, we know those go there so that we can get back to x squared. And numbers that multiply to be positive 2, but add to be positive 3 would be positive 2 and positive 1. And then in our denominator, we're going to factor that, x and x. Numbers that multiply to be negative 7 and add to be negative 6, well, the only numbers that multiply to be 7 would be 7 and 1, and if I want them to add to be negative 6, we make that negative and make that positive. After we factored, now we look to see what can simplify, in which case the x plus 1s. So our final answer, x plus 2 over x minus 7.